difference in amperage between the feed conductors and the generator output can be attributed to several factors. Firstly, generators have inherent inefficiencies due to mechanical losses, such as friction and heat, and electrical losses, such as winding resistance. These inefficiencies lead to a higher amperage draw at the generator output compared to the amperage drawn from the utility power source. Secondly, power factor plays a significant role. Power factor is a ratio between true power, measured in watts, and apparent power, measured in volt-amps. A power factor below 1 indicates inductive loads such as motors and transformers that consume reactive power. Reactive power does not contribute to useful work but increases the current draw. The generator may be supplying reactive power to meet the demands of these inductive loads. Thirdly, starting surge currents can cause a temporary increase in amperage draw. When certain appliances or devices, such as air conditioners and refrigerators, start up, they draw a higher current momentarily. This surge current can briefly increase the amperage draw from the generator. Fourthly, frequency differences can contribute to the issue. Utility power operates at a specific frequency, such as 60 Hz in the United States. Generators may not perfectly match this frequency, which can lead to power fluctuations and increased current draw. Other possible causes include incorrect wiring or loose connections, an oversized generator relative to the load, and faulty generator or panel components. To determine the root cause, it is recommended to take several steps. 1. Check the wiring and connections for any errors. 2. Measure the generator output voltage and frequency to ensure they are within specification. 3. Consider reducing the load on the generator by disconnecting select circuits to isolate any potential issues. 4. Consult with the generator manufacturer or a qualified electrician for further troubleshooting. Understanding these factors can help identify why the generator amperage is higher than the utility feed amperage. When a generator operates, it converts mechanical energy into electrical energy. This conversion process is not perfectly efficient, and some energy is lost along the way. These losses manifest as heat friction within the engine and electrical resistance in the generator's windings. Consequently, the generator needs to work harder to deliver the same amount of usable power as the utility grid, resulting in a higher amperage draw. The power factor is a crucial concept in AC circuits. It represents the phase difference between the voltage and current waveforms. In a purely resistor circuit, the voltage and current are in phase, and the power factor is 1. However, inductive loads such as motors and transformers cause the current to lag behind the voltage, resulting in a power factor less than 1. This lagging current draws reactive power, which doesn't contribute to real work but still burdens the generator. Generators are typically rated in volt-amps, which is the apparent power, rather than watts, which is the real power. If the power factor is low, the generator must apply more volt-amps to deliver the same amount of watts, leading to a higher amperage. Many appliances, especially those with motors, draw a significantly higher current when they start up compared to their normal operating current. This is known as the inrush current or starting surge. For example, an air conditioner compressor might draw 5 to 7 times its running current during startup. This surge is necessary to overcome the inertia of the motor and get it running. The generator must be capable of supplying this surge current, even if it only lasts for a short time. If the generator is undersized, it may struggle to provide the surge current, leading to voltage dips and potentially tripping circuit breakers. The frequency of the AC power is critical for the proper operation of many devices. In the United States, the standard frequency is 60 Hz, while in Europe, it is 50 Hz. Generators are designed to produce power at a specific frequency, but they may not always maintain perfect frequency regulation, especially under varying loads. If the generator's frequency deviates significantly from the utility frequency, it can cause problems with certain devices, such as timing circuits and sensitive electronic equipment. It can also lead to increased current draw as the devices attempt to compensate for the frequency difference. To effectively troubleshoot the issue of higher generator amperage, several diagnostic steps can be taken. Firstly, a thorough visual inspection of all wiring connections is essential. Loose or corroded connections can create resistance, leading to voltage drops and increased current draw. Check all connections at the generator, the transfer switch, and the load panel. Ensure that all wires are properly sized for the load they are carrying. Secondly, measuring the generator's output voltage and frequency is critical. Use a multimeter to verify that the voltage is within the specified range, typically 120 volts or 240 volts, depending on the wiring configuration. Also, use a frequency meter to confirm that the frequency is close to 60 Hz. If the voltage or frequency is significantly off, it indicates a problem with the generator itself. Thirdly, systematically reducing the load on the generator can help isolate the source of the high amperage draw. Disconnect non-essential circuits and monitor the amperage. If the amperage drops significantly after disconnecting a particular circuit, it suggests that the devices on that circuit are contributing to the problem. Investigate those devices further to determine if they have high inrush currents or low power factors. Fourth, consulting with the generator manufacturer or a qualified electrician is recommended if the problem persists. They have the expertise and specialized equipment to diagnose complex generator issues. They can perform tests such as load bank testing to assess the generator's capacity and performance under different load conditions. They can also check the generator's internal components, such as the voltage regulator and automatic voltage regulator, for any malfunctions. It is also important to consider the generator's size relative to the load it is supplying. If the generator is significantly oversized, it may operate inefficiently, leading to higher amperage draw. On the other hand, if the generator is undersized, it may struggle to supply the load, especially during startup surges, resulting in voltage drops and potential damage to the generator. Selecting the appropriate generator size is crucial for optimal performance and efficiency. In addition to the above factors, other possible causes for high generator amperage include faulty appliances or devices. A malfunctioning motor, for example, may draw excessive current. A short circuit in a wiring system can also cause a significant increase in amperage. Regular maintenance of the generator is essential for its reliable operation. This includes changing the oil, cleaning the air filter, and inspecting the spark plugs. A poorly maintained generator is more likely to experience problems such as voltage fluctuations and increased current draw. Also, make sure that the generator is properly grounded. A good grounding system helps protect against electrical shocks and reduces the risk of damage to the generator and connected devices. Use appropriately sized grounding conductors and ensure that all connections are secure. When connecting a generator to a house, it is essential to use a transfer switch. A transfer switch prevents backfeeding of power into the utility grid, which can be dangerous for utility workers and can damage the generator. Transfer switches also allow for easy switching between utility power and generator power. Manual transfer switches require manual operation, while automatic transfer switches automatically switch to generator power when the utility power fails. Another important consideration is the type of fuel the generator uses. Generators can run on gasoline, diesel, propane, or natural gas. Each fuel has its advantages and disadvantages in terms of cost, availability, and emissions. Gasoline generators are typically less expensive but require more frequent refueling. Diesel generators are more fuel efficient but produce more emissions. Propane and natural gas generators are cleaner burning but require a connection to a propane tank or natural gas line. When operating a generator, it is important to follow all safety precautions. Never operate a generator indoors or in an enclosed space, as this can lead to carbon monoxide poisoning. Always place the generator in a well-ventilated area away from doors and windows. Use a carbon monoxide detector to monitor the levels of carbon monoxide in the area. Also, store fuel safely in approved containers away from the generator and other sources of ignition. It is also important to protect the generator from the elements. Rain, snow, and extreme temperatures can damage the generator and reduce its lifespan. Use a generator cover to protect it from the weather. Also, make sure that the generator is placed on a level surface to prevent it from tipping over. In summary, the difference in amperage between the feed conductors and the generator output can be attributed to a variety of factors, including generator inefficiencies, power factor, starting surge currents, frequency differences, incorrect wiring, oversized generator, and faulty components. To determine the root cause, it is recommended to check the wiring, measure the generator output voltage and frequency, reduce the load on the generator, and consult with a qualified electrician. Regular maintenance and adherence to safety precautions are essential for the reliable and safe operation of a generator. Remember, electrical work can be dangerous, so it is always best to consult with a qualified electrician if you are not comfortable working with electricity. They have the training and experience to safely diagnose and repair electrical problems. By understanding the factors that can affect generator amperage and taking appropriate troubleshooting steps, one can ensure the safe and reliable operation of a generator system. This involves a combination of theoretical knowledge, practical skills, and attention to detail. Regular maintenance, proper installation, and adherence to safety precautions are essential for preventing problems and ensuring the longevity of the generator. In the field of electrical engineering, the principles of power generation and distribution are fundamental. Generators play a crucial role in providing backup power during outages and in remote locations where utility power is not available. Understanding the characteristics of generators and the factors that affect their performance is essential for electrical engineers and technicians. The study of power factor is also an important aspect of electrical engineering. Improving power factor can reduce energy losses and improve the efficiency of electrical systems. Power factor correction techniques such as using capacitors are commonly employed in industrial and commercial facilities. The analysis of surge currents is also critical in electrical system design. Surge currents can cause stress on electrical components and lead to premature failure. Surge protection devices, such as surge arresters and transient voltage suppressors, are used to protect electrical equipment from surge currents. In addition to the technical aspects of generators, it is also important to consider the environmental impact. Generators can produce emissions that contribute to air pollution. Efforts are being made to develop cleaner burning generators and to reduce the emissions from existing generators. The use of renewable energy sources, such as solar and wind power, can also reduce the reliance on generators. The field of power generation is constantly evolving, with new technologies and innovations emerging all the time. These technologies are aimed at improving the efficiency, reliability, and environmental performance of power generation systems. Staying up to date with the latest advancements in power generation is essential for electrical engineers and technicians. The principles of electrical safety are also paramount in the operation and maintenance of generators. Electrical shocks can be fatal, so it is essential to follow all safety precautions when working with electricity. This includes wearing appropriate personal protective equipment, such as gloves and safety glasses, and using insulated tools. It is also important to de-energize electrical circuits before working on them. Lockout-tagout procedures should be followed to prevent accidental energization of circuits. By following these safety precautions, one can minimize the risk of electrical accidents. In conclusion, understanding the factors that can affect generator amperage is essential for the safe and reliable operation of a generator system. This involves a combination of theoretical knowledge, practical skills, and attention to detail. Regular maintenance, proper installation, and adherence to safety precautions are essential for preventing problems and ensuring the longevity of the generator. The field of power generation is constantly evolving, with new technologies and innovations emerging all the time. Staying up to date with the latest advancements in power generation is essential for electrical engineers and technicians. The principles of electrical safety are also paramount in the operation and maintenance of generators. Electrical shocks can be fatal, so it is essential to follow all safety precautions when working with electricity.